going on? Today we'll be talking about...
So we have this intuition that what we'd like to do instead is we'd like to take all of the images and simultaneously feed them into a single neural net and directly output in vector space.
This chart represents the structure that we talked about earlier.
Right, one lane, one
lane,
traffic.
right,
one
traffic,
object,
and then we want to like fuse that through some kind of black box, which then gives us the vector space.
So in this case, would it be that all these camera feeds are like stitched together into like one mega image, kind of like how they had that 3x3 grid earlier? So this is like one video feed, one video feed, one video feed.
Right.
Each video feed is coming out of this 3x3 grid.
Right.
So there are two problems with this. Problem number one, how do you actually create the neural network components that do this transformation? And you have to make it differentiable so that end-to-end training is possible. And number two, if you want vector space predictions from your neural net, you need vector space data sets. So just labeling images and so on is not going to get you there. You need vector space labels. We're trying to have this bird's eye view prediction instead of image space predictions.
This is such a good image representation of the problem that they're trying to solve.
Right.
Right. You want to have a top-down view of your surroundings, and this is you.
Right.
And here are the three different cameras. Right. Approximately where does all of these correlates to on a top-down view?
So in order to solve this issue, we use a transformer to represent this space.
So I'm guessing the transformer that they're referring to is from this paper, Attention All You Need.
Yes.
Transformer.
Yeah, this is the same transformer used from like translation. I remember seeing the queries and the key values.
Effectively what this does is you initialize a raster of the size of the output space that you would like, and you tile it with positional encodings with sines and coses in the output space. And then these get encoded with an MLP into a set of query vectors. And then all of the images and their features also emit their own keys and values, and then the queries, keys, and values feed into the multi-headed self-attention. And so effectively what's happening is that every single image piece is broadcasting in its key what is it a part of. So hey, I'm part of a pillar in roughly this location, and I'm seeing this kind of stuff, and that's in the key. And then every query is something along the lines of, hey, I'm a pixel in the output space at this position, and I'm looking for features of this type. Then the keys and the queries interact multiplicatively, and then the values get pooled accordingly.
Because it's like this context that you need for doing like machine translation.
That's right. I'm at this position, and I am a pole. I'm at this position. I am a traffic light. It's possible that it might be in this paper, so we should dig in to see if we can find this architecture.
What's this repeater image that they are referring to?
They said this is the back mirror. It looks like just like some image preprocessing. Flatten the barrel distortion. So before the image gets fed raw into RegNet, they like clean up the image first and then feed it into RegNet. So they call this like the virtual camera.
Right.
So here are some of the results. So on the left, we are seeing what we had before, and on the right, we're now seeing significantly improved predictions coming directly out of the neural net. This is a multi-camera network predicting directly in vector space, basically night and day. You can actually drive on this. And this took some time and some engineering and incredible work from the AI team to actually get this to work and deploy and make it efficient in the car.